Without any further ado, let's move on to our session on getting started with Azure Machine Learning services. And today we have Henk Boelman as our speaker. To talk a little bit of Henk, he is a cloud advocate specializing in artificial intelligence and Azure with a background in application development. He is currently a part of the regional cloud advocate team in the Netherlands. Also, he was a Microsoft AI MVP who worked towards building lots of AI-powered platforms on Azure. He's also a very well-known and a regular speaker at user groups and international conferences. So, hello, Henk. Welcome back. Welcome to our Dev Day 2021. The virtual screen is all yours.
Thank you for that introduction. Let me start with sharing my screen. Cool, it looks like it is working and you should all be able to hear me. So hello everyone and welcome to my session Getting Started with Azure Machine Learning. My name is Henk Boelman. I'm a cloud advocate based in the Netherlands and my job is to make you all successful with AI on Microsoft Azure. And today I'm going to give you an introduction on how you can train your own models using Azure Machine Learning. So let's get started. So what is the agenda of today? I'm going to give a brief introduction about machine learning on Azure, all the capabilities we have and what you can do with it. And then we're going to dive into a demo and we're going to create a Simpsons classification model using PyTorch and using Azure Machine Learning. So machine learning on Azure is divided in kind of 5 layers. So first of all, we have our pre-trained models. So these are models that we at Microsoft train for you and expose to an API. So you can call an API, send an image, and then it will tell you what is on the image. You can send some audio in a WAV file and we will transcribe it. And we can actually translate it for you. We can put it in Azure Search and make it even browsable. But sometimes you want to create your own models with your own data. Then you need to choose a framework. And the good news is that we support any framework or the most popular frameworks, all with Azure Machine Learning. We have some services to make it a little bit easier for you. So we have Azure Databricks, Azure Machine Learning, and Machine Learning Virtual Machines. So machine learning virtual machines are very handy when you start with Azure Machine Learning or with machine learning in general, because it is quite a hassle to get your machine installed with all the right Python versions, all the right TensorFlow versions, your GPU drivers, all those things you need. And in these machine learning virtual machines, it is all installed by default. So you just have to create the machine, wait 10 minutes, and you have your own workspace in the cloud. For machine learning, you always need CPUs, GPUs. So we have a lot of them in Azure. So you can scale them up, scale them down, and you pay for what you want to use only. Finally, we can help you deploy these models. We can give you the model so you can deploy it in your own infrastructure, or we can help you deploy it in the cloud, and we can even help you deploying it on the edge using IoT Edge. So cognitive services, I mentioned them a little bit. So cognitive services are pre-trained models in the cloud and on the edge. So the cool thing is that they live as an API in Azure. So you create your endpoint, let's say your Vision endpoint, but some of these models you can actually, or these cognitive services, you can actually pick up and run in your own infrastructure. So what does it mean? You can download a container, build a container and deploy it in, for instance, your local Kubernetes cluster, or even run it locally on your desktop with Docker Desktop. So the benefit of that is that you are closer to actually the model and you don't have to send like thousands of images over the internet. But the only thing the container will do is send every like 15 minutes some billing information to the endpoint in Azure, and that's it. So the cognitive services are divided in 4 regions. So we have vision, speech, language, and knowledge. So vision is to make your application see. Speech is to make your application talk and listen to you, and language is to make your application understand what is going on. And knowledge is there if you want to tap into the wider knowledge of the internet. But enough about cognitive services. We are going to create our own cognitive service using Azure Machine Learning. So what is Azure Machine Learning? Azure Machine Learning is a fully managed cloud service that enables us to kind of work together on machine learning models, and from data all the way up to deploying our AI solutions. So for this example, for this demo, for the rest of the presentation, we're going to focus on a classification model for Simpsons Lego figures. So our question we're going to answer is it Marge, is it Homer, is it Lisa, is it Bart? Because all machine learning projects should start with a question. So if your question is not defined very specifically, probably your model will kind of fail. So before you start with any machine learning project, always ask yourself the question, which question is my model going to answer for me? So in this case, is it Marge, Homer, Lisa? Or for that, we're going to use PyTorch and my Simpsons Lego dataset. So you can download this dataset and play around with it yourself. It's available on my GitHub. On my GitHub/Henky/dataset-Lego-figures. It contains 10 classes of Simpsons Lego figures, and every class has around 50 images. Kind of the minimum you need to actually do this. So what are we going to use? We're going to use Azure Machine Learning. We're going to use PyTorch. We're going to use a GPU cluster, and we're going to deploy this model in the cloud. So let's have a look how this would work in a real world scenario. So we would have a data scientist that will use Jupyter Notebooks, some kind of version control, Azure Machine Learning to train the model, and then actually register the model. But a model needs software around it. Otherwise, it kind of does really nothing. So someone has to write some code that will load in the model and run images through it. And probably the developer will not work in a Jupyter Notebook to do that, but will have his or her own favorite tools to do that. Visual Studio Code or anything else. Use a different GitHub repository because those tool life cycles can be completely different. Use some build pipelines and then probably register this Docker container and this code in an Azure Container Registry. Then the third thing we need is someone will actually deploy and manage our code in production. So for operations, it is kind of like any other container. So it will pick it up and it will deploy it using a deployment pipeline in an Azure Community Service, in an Azure Container Instance, or wherever you want. And then finally, our client can connect to that endpoint and send images to it. So what is Azure Machine Learning Service exactly? So it is not just one thing. It is a set of cloud services that can be controlled using the Python SDK and the Azure CLI. So this set of cloud services consists of a blob storage, application insights, a key vault to manage our secrets, and the actual Azure Machine Learning service. And this set of cloud services controlled with the Python SDK enables us to prepare our data, build models, track experiment, and finally deploy these models into the cloud. So to do this, we need to go to kind of like 3 phases. First, we need to prepare our environment. Then we can start experimenting with our model and our data, and then we can deploy our model into production. So let's start with preparing and setting up our environment in Azure. So to do that, we can do that in multiple ways. We can go to the Azure portal, we can use Visual Studio Code, and we can use the Python SDK, and we can also use the Azure CLI. So all these things are fine, as long as you document how you're going to create this environment so that when someone deletes the environment, you can actually recreate everything. So creating a workspace. From now I will just going to show you how to do everything in Python. Because when you show it in code, you can actually version it and everyone can reproduce it. So let's start with creating a workspace. So we install the Python SDK and then we say workspace.create. We give the name, point to the subscription ID, a resource group, and a location. So it will create our workspace and all the other Azure parts with it. And we say workspace write out a configuration file. When you've done that, everyone can say workspace from configuration file, from config, and connect to that workspace. So by choosing the location for your workspace, you already make kind of a decision for your Azure Machine Learning project, because later on we're going to choose compute. Like we want to have GPU clusters or normal CPU clusters. So you kind of need to look before you create this workspace if the compute you want to use is available in this workspace. So West Europe is always a safe bet because most of the compute is available there. So now we have our workspace, and this is how the workspace looks. So it lives kind of in the Azure portal, but there is also a different interface where you can control your whole machine learning workspace with. And that is called ml.azure.com. You log in with your Azure credentials and you will see all the workspaces you have access to. So this is a workspace. And let's zoom into the basic things you need, or the basic things of the workspace actually. So let's zoom in. So Azure Machine Learning. Let's start with datasets. Here is where our datasets live. So we kind of upload something to a data store, and from there we create a data set, and our machine learning project will use that data set. So here we register kind of data we're going to use, and we can have multiple versions from it. Then we have experiments. Every time we try to train a model, a new run is created under our experiment. So, and this is really cool because now we can see the different outputs of those runs, have some graphs and see which experiment or which run performs better. So we can go to the optimal model. Then there are models. Here we register our version models. So when we're done, some artifacts are delivered from a training run and we can register that. It's kind of like a NuGet repository. We check in a model, let me say this is Simpson's model, and then this is number 5. So everyone can connect to that model registry and pick out Simpson's model number 5 and use that later on in a solution. Then we have endpoints. Under endpoints is where your deployed models live. So when you have a model, you write some software around it, and then we deploy it to an endpoint. And this can be like an Azure Kubernetes service, it can be an Azure container instance, or a managed endpoint. Finally, you can also find the pipeline endpoints there, and that is where your training workflows live. So these are set of steps that will do all kind of different tasks. We will not dive into that in this presentation, but if you're doing some more advanced and recording Azure machine learning, this will be definitely a feature you want to check out. Then we have compute. Under compute, we manage all the different type of computes we need. We have compute for running our notebook, we have compute for training, and we have compute for inference. So all that is managed from there. Finally, we have data stores, and data stores, you manage the connections to where your data is. So it doesn't actually have the data. It manages the connections to your blob storage, to your SQL servers, to your data lake. And all those secrets are safely stored in an Azure Key Vault. So you can use in your code a reference to the data store. So we actually don't have to kind of have secrets in our code. So that is really nice. So now that we have our workspace, I will show it to you a little bit more in depth later. We can start creating compute. So here I say Azure Machine Learning Compute, provision for me a cluster with a minimum nodes of 1, maximum node of 6, consisting of standard NC6 machines. So these standard NC6 machines are the cheapest machines that have a GPU, an NVIDIA, Tesla, something. They have it, and they have one. These now are on actually fairly priced. They're around $200 a month if you don't shut them down. So I say here minimum nodes is 1, maximum nodes is 6. That means there is always one node up and running. So I'll always pay for that one node. So you better say minimum nodes is 0. This adds a little bit of time because it has to provision, spin up that cluster for you, but you don't have to pay if you don't use or there is no job running. It will just scale it down after like 3 minutes of inactivity. So next we create this cluster. Then we need to have storage, data. So there is always a default data store, but sometimes you already have your data somewhere, and so you can connect to other blob storage containers, even if they are with outside of the subscription where Azure Machine Learning is running in. So you say give the name of the data store, the container name, the account name, and the account key, and everything is safely managed within your data store. So nobody else has to see your secrets here. So let's have a look at the workspace. So here we have our Azure Machine Learning workspace. So here we have our Azure Machine Learning workspace. So this is my workspace. You see, there are a lot of things here. So let's go from up to down. So here, this is our home pane. Here we see recent runs, computes, models, and datasets. So these are basically shortcuts to all my recent resources. Below, we have documentation. This will link you to Microsoft Learn, where you'll find a lot of tutorials about how to do certain things. Here we have some quick things, like we can go to the designer, automated machine learning notebooks, and here we can create something new. So this is kind of the dashboard. So notebooks we will run later. So this is automated machine learning, the designer. So automated machine learning is there to help you automate and automatically pick the right model for your solution. So you bring your data, you specify what you want to basically learn, and it will pick the right algorithm for you. This is the designer. This is kind of a visual interface where you connect certain machine learning steps. So you select your data, you drag on, like, hey, this is a PyTorch model, scikit-learn model. You train it, and then it will deliver. So basically, it is a visual interface on what we are going to do today in code. So here we have our data sets. We have here our Lego Simpsons V3 dataset. This is the dataset we're going to use. So we see where it is stored. We see how we can consume it. We can actually explore this dataset here. And let's see, here is Bart. And we can create new versions from it. Here we have, again, some tutorials on how to do it. Under experiments, we will see all the experiments that are currently going on or have finished. So here is the Simpsons PyTorch, Simpsons classification is here. We have some automated machine learning here, Simpsons demo. So you see, I do a lot of things with Simpsons. We have pipelines. We're going to skip that. And here we have all our models. So this is the last model we have, which I have done. We will see them later. We see the different type of versions from that model. We see where these models are deployed. And we can here have some data sets on it. Endpoints, I only currently have one endpoint up and running, but the most important thing we're going to zoom in is compute. So this is my compute, is a compute instance. So these compute instances run your notebooks. You can open Jupyter Lab, Jupyter, VS Code, RStudio. You can even have a terminal. And I'm just using a cheap virtual machine for this, a standard D2 V2 machine. So you have to stop them manually because otherwise they will keep running. Compute clusters, these are the clusters we use to train. So I have two compute clusters here. I have Optimus Prime and I have Bumblebee. So Optimus Prime consists of standard NC6 machines. So we can click on it, and here we see it is an NVIDIA Tesla K80 GPU, and I have one. It's dedicated, and here we see that I have 8 nodes up and running. We're going to use these ones to actually train our model. I have 6 cores, 56 gigabytes of RAM, and 380 gigabytes of disks. A lot. So the current node count is 8, and the only thing they're doing now is eating my money. Here we have the different type of nodes. We see to deploy them nicely in our VNet, give them different ports, IP addresses. See the runs that have performed on there. Then we have data stores finally, and here we see the workspace default data store. This is the data store I'm mostly using. Can create a data set, see our authentication, and we can actually browse what is on there. And here we see basically what we also saw there under data sets, but then on the file system. So that brings us to our notebook. Click. So these are Jupyter Notebooks. So if we go to Notebooks, we will here have a file share, which is on your workspace blob, basically, and mounted in your compute instance. So we have a few notebooks here, and we are opening this notebook. So to make some space, I can do this. And here is this really cool thing, the table of content we can put on. So these are the steps we're all gonna go through. Don't want to do a survey now. So let's start with connecting to our workspace. So I have a lot of dependencies, and I like to put them all up in the top so we don't lose too much space. Later on, I will zoom a little bit more so everyone can see this quite right. And let's connect to our Azure Machine Learning Workspace environment. So we run this cell. I say workspace from config, connect, and print my workspace name. Connect to my compute target Optimus Prime, connect to my default data store, and connect to my Simpsons PyTorch experiment and print those details out. Then this is, we already looked at the data set, but this is how you will actually get the data. So I'm downloading the data in a folder called data. Then I'm unzipping my data set. Then I say upload, data store uploaded to this path, Simpsons Lego v3, overwrite, and so on. And then from the data in that data store, we are going to create a data set from these images. So I say data store path, you find it here, and then say dataset file from files. Done. Then you register the dataset as Lego Simpsons v3 and create a new version when you do that. So I've already done that because nobody wants to watch me uploading 500 images. So I can connect to this dataset by simply saying dataset get by name Lego dataset v3. So let's roll that, and then it will print us the ID of the dataset. So we can have a quick look at the dataset. And here we go. We see the different classes we have. So next up is to train the model. And for that, we will go back to our presentation. So what have we done to set everything up? We created the workspace, created compute, set up our storage. That's what we have done to get started. And now we can start working together in Azure Machine Learning. So now we have to start experimenting with our model and our data. So first we create an experiment. Second, we create a training file. And this is the file where all the magic happens in. So for our example, I went to the website from PyTorch. I downloaded the classification example with transfer learning, and I just picked up that script. I will show it to you in the demo. And then I'll also show you what changes are made so the script could run perfectly on Azure Machine Learning. Then we need to create an environment where the training script is going to run in. So you have two options from there. You can use a curated environment, or we can use a custom environment. So curated environment is basically a container that is maintained by Microsoft, and you can just pick out and use, and has all the things you need installed to train, in our case, a PyTorch model. If you want to use your own environment, your own custom environment, you can pick a base image, and then you will say which packages you need to have installed in that environment. It will build a container for you, and then later on you can reuse that environment in your Azure Machine Learning solution. So if you're working with 10 people in your Azure Machine Learning workspace, everyone can use that same training environment. Then we need to specify how your training script is going to run in. So first, we parse some incoming arguments like, hey, where is the data? And some other parameters. Then we need to tell it where the training scripts are. And then finally, we combine that in a script run configuration. We tell where the scripts are, which script it has to execute, which compute target it has to use, and which environment it has to use. When we have that, we submit that experiment to our cluster. And then it will start executing our training script in the Docker container on our compute cluster, and will stream back outputs to our experiment. And then finally, we are going to go to the demo to actually train our model. So first we need the training script. Like I said, I took this script from the PyTorch website, and I've added a few things. I added the capability to parse incoming arguments and connect to our Azure ML core run, so I can actually connect to Azure Machine Learning and give back some extra logging. Connect to my run context and then parse some incoming arguments like where's the data and how many training rounds we have to do. Then this is as is, so we prepare our data set and then we start training the model, but first we check if we're training on a CPU or on a GPU. We train our model, we go into the loop, and then I've added some extra logging here. So I can say run log, and because this is a loop, it will log a float under every time the same name. And when Azure Machine Learning detects it is an array of numbers, it will automatically start drawing a graph for you, which is really cool and really handy. Then finally, when the training is complete, we pick the best one, and then we should never forget to save the model, because this is running distributed in a container on a cluster. So what happens is it will just shut it down, and if you don't copy anything over or put anything in the outputs folder, all your work will be lost. So save your model in the outputs folder before your script ends. So then we have our script, and we need to start with where the script is going to run. So this script will perfectly run in an Azure Machine Learning PyTorch 1.6 GPU curated environment. So we'll just have to pick that environment out. Then I have to specify how my script is going to run. So I'm taking my dataset, Simpson's dataset, as named input Simpson and mount it. So what this command does is it mounts my dataset as a virtual directory in that container that runs on our cluster. So this will be parsed with where the virtual directory is, and because I've done this, it will automatically mount that with the script run config. Now my script is just looking into a virtual directory. Then I specify like 10 training rounds, let's do 10. Then where are my scripts? Train.py, project folder, train.py, which compute target? Okay, that is Optimus Prime, we just configure it up. The PyTorch environment, we configure it here, and then the incoming arguments that we have here. So let's run it. So now I'm submitting this to my experiment. Here, it went to the state preparing, and then there is this nice widget that we can actually see what is going on. So you see that one of the 8 nodes is actually doing something now. And it will be training, it is running. So here it is getting the container. It's going to deploy it. Of course, there is a newer image, so that is always good, but probably adds some time to the deployment. So show the active logs. So now it is deployed, then you will see more log files. So when the driver.log appears here, it is actually starting to train. So let's go back to the presentation while we wait for this and have a look at what is actually happening underwater. So we have this Azure Machine Learning notebook where we were in. When we said submit our experiment, it snapshotted the folder with my training script and all the other resources that are in the training folder and copied them over to the experiment. Then it started to create this Docker container, a Docker image, according to my specifications, or picked out a curated environment. Then it deployed that Docker container to my Azure Machine Learning compute and mounted my data stores to that compute. Then launched my training script and started streaming the output of the training script and all the other log files back to my experiment. And then, because we have the Azure widget installed, I could see and follow everything that was going on in my experiment by connecting to the experiment. And then finally, when the training script is done executing, it copied over everything in the outputs folder back to my experiment. So with that said, the only thing we need to do now is to register the model. So I'm just saying Simpsons AI model, you can find everything in the outputs to, folder and go ahead and register it. So let's see if our container is deployed and we are actually starting to train. Yeah, we see the driver's log here. We see that it is running, and here we see our graphs. So these graphs are generated by the line in the training script that said run.log. So this now at number 2. So luckily we've set it up to number 10. So a few more times, and then it will be here. So what we can have a look at in the meantime is we are going to go to experiments, see our experiment here. Yeah, I know it is running. Here we see all the different type of outputs from all the different runs. But here we see our now under snapshot, we see our training file. Our other training file on the outputs and logs, we can actually see what is going on. We can see here all the logs, and here we see that it is done and has put our outputs with our labels and with our models. It's finalizing. Here it is already completed. So now our model is done. And like I said, it is basically just 2 files. So we can connect to previous run, but what we want to do is actually register that model now. So we say run the register our model, give it, we say dev days. Here we give it a nice tag, so we know that it's actually real what we're seeing. So we call it Simpsons PyTorch. You can find it in the outputs directory. We can specify the framework and the version of the framework. We can give it a nice description. We can give it tags, and we can specify a preferred resource configuration. So I'm saying if you want to run this model, you might want to have 1 CPU and 2 GB of memory. You can overrule it later, but it's always nice to have an indication. So here I will say run, and now Simpsons PyTorch model with version 74 is registered, which we can now see back here on the models. Click on the model, and here see conference dev days. So this is the model we just trained. We see different versions of the model, the artifacts. So here we see that it is only everything in the outputs folder, these 2 files. And what we can do now is we can see which experiment has generated it and which run. So we can click on the run. On the run, we see which compute target that was executed. And we can see which environment was used, which GitHub repository, and we should be able to see which data set was being used. So now we can go back to the data set and actually track down and figure out if something is wrong. Maybe it was the data, and we can actually go back and see it from there. So here we are in models. Now we have our registered model rightly tagged in model management in Azure Machine Learning. So step 2, what we've done is we've created an experiment. We got a training file that will actually train our model. We configured how this script had to run and in which environment. Then we submitted the job to our AI cluster, and we finally, when it was done training, we registered the model in model management. So now it is time to deploy it in production, development, whatever environment you want. For that, we need 3 things. We actually need a model. We need a script that will load in the model and run on every request. And we need an environment file that will specify how the environment has to look. We wrap those 3 things together, and then we will get a Docker image. And that Docker image we can deploy. So how does the scoring script look? There are 2 methods you need to implement. There is an init method that will load in your model. Loading in models takes time, so you only want to do that once. And then there is the method that will be executed on every incoming request. So you parse the incoming URL, you shape the data for you so that it is right to run through your model. You run it through the model, and then you return the result. Environment file. It's a conda environment file that will specify which packages need to be installed in that container. You combine those 2 to an inference config. So you specify your runtime, it's Python. The script is core.py, and then you have the conda environment file, which will specify how it is how your environment should look like. Then, when you have that, you can specify how to deploy that inference config, that container you have. You can do that to an Azure Container Instance, to an Azure Kubernetes service, or to the new managed endpoints. So the easiest way is to deploy to an Azure Container Instance. So we say Azure Web Service deploy configuration. So we can pick that from the model, but we can also overrule that here. 1 CPU, 2 gigabytes of memory. And then we say model deploy. We specify which workspace. We give it a name. We specify which models, which inference config has to be used, and which deployment configuration has to be used. Wait a few minutes, and then it is there. Deploying to AKS, the only thing extra you have to do is connect to your AKS compute target. Let's have a look at how we can actually deploy things. So we have our model here, and now we go back to our notebook. So let's first, before we are going, actually download our model and see if it is any good. So this script is very similar to the script we're going to put into the container, to the deployment. We import our dependencies, we load the model, load in the labels, and then we have a scoring function. So we shape our incoming image to the right size, create an input tensor, check if there is a GPU available, run it through the model, and then actually return the result. And we're doing that for a list of images that is available in data/test. And then we print the result under it, and that results in this image. So here we see that it is doing not so good on Mr. Burns today, but pretty well on Homer, Lisa, Chief Wiggum, Marge, Krusty. So we trained a fair model with only 10 rounds of training. So now I think I'm ready and we can deploy it to production. So we rewrote the script a little bit so that the first thing we do is load the model. Then there is a run method that will get the URL, we will download it, we transform it, we check if there is a GPU, and then we return the result. We specify our environment. We call it, we create a new environment for this. So I don't want to take a curated environment. I want to have this fresh environment that is just optimized for my model. So I call it Simpsons Inference. I install HTML default, PyTorch, Pilla. That's it. And then from that, we create an inference config. I think the entry script is score.py. Okay, I will actually have to run these cells, of course. But otherwise it doesn't work. So we have our inference config here, and then we can deploy that to an Azure container instance. So the score.py and the environment file. So let's connect to the latest version of the model. This is our 74 version. And then we say Azure Web Service deploy configuration, ACI Web Service deploy configuration, CPU cores, memory, description. You can say the days here. So I'm just taking this configuration now from the model. So let's run that. And then finally we can deploy. So I say Azure Container Instance Service model deploy. Give the name of the workspace object. Simpsons, give it a name. Link to my model. Inference config, deployment config, and override if it already exists. And then wait for the deployment to happen and show us the output, which should be appearing here. So it would be super cool if it would actually start deploying pretty soon, because then we would see our endpoint here under endpoints, because every deployment ends up here under endpoints. So when this is done, we can actually connect to the endpoint. If we want to connect to a previous one or something else, and then we can print the scoring URI. And this is the URI that is, okay, here we're doing. This is the URI where we can send our requests to. We can do this request. We can use Postman for it. We can use the built-in interface here on the endpoints, but we can also use a very easy method in using the SDK. So here we see it is already deployed it and it's printed out our endpoint. So now you can actually start posting images of Simpsons to this endpoint, and it will tell you who is on the image. So let's do that. So here I have a list of URLs of all the different classes that are there. And this small script will go through these URLs and then uses this method as a container service run, input data and dumps, creates this JSON thing. I hope that is not the case. It's actually cancelled. Let's try again. Then you ask yourself, what are you busy with? Kernel is idle, kernel is busy. ACI service, oh, this is not good. So what we can do is we can connect to that ACI. It completely reset it. So we start here. Let's see if we can, yeah. So we are back, so we go back to the bottom. We connect to our ACI web service. So we need first to connect. So probably, oh yeah, luckily we don't have to log in. So now we have our workspace from configures and we are connected to Cybertron again. We can connect to our ACI web service now. We can print scoring URI again. And now we should be able to post all those images to our ACI service, run, dump the input, and we should see all the predictions here. You see it is the same model because it is not doing that well on Mr. Burns. So here we go. It is running in an endpoint now, and we can see this endpoint here. We can test it here. You can see how we can consume it. There's some handy scripts. You can see the deployment log file on. Very handy if something went wrong. But the cool thing now is that under model, you can click here. We can actually see on the endpoints in which endpoint this one is running. So that is super cool. So one thing I wanted to show you before we close off is the automated hyperparameter tuning function. So you saw me putting in like one parameter, how many training runs it had to do, but in a real world scenario, you have a lot of these parameters and you mostly have to sample them yourself. So you choose something between for the learning rate, number of players, and it results in all these different type of configurations. And you have to run it over and compare the outputs. So you have a data set, you have training algorithm 1, and you have a parameter that results in model 1. You change the other parameter, model 2, and you all have to compare those models, which is really complex. It is repetitive, time-consuming, and very expensive. So we have something in Azure Machine Learning that is called automated hyperparameter tuning that will actually do those things for you. So what it does, you can sample the input by giving like, hey, pick random values between this number for this parameter, for that parameter, and then it will monitor for you the output parameter you want to monitor, in my case, the accuracy, and then it will pick the best set of parameters for you. So let's see if we can improve our Simpsons model with using some automatic hyperparameter tuning for that. So it starts all the same. We're still connected to our kernel. So here we are, we connect to our workspace. The same as here. We connect to our data set. I have a different data set because I added a few more classes to make the model a little bit more difficult. We can preview that. So you can see I've added a few different Lego figures. So I've added this one, this one, this one, and this one to make it a little bit more difficult. So let's create the training script. So the only thing I've added more to this training script is the file that it will log the final accuracy of the model. That is the only thing. So we have it here. We use the same environment to run it in. Then this is the thing we're going to look at. Now the script run configuration is the same. The arguments in this case is only where the Simpsons data set is. And then I'm sampling 3 other inputs, the number of epochs, the learning rate, and the momentum. And I let it pick random values between this range, for instance, and between here. I'm going to actually run it first. So we can should be able to see it within the time. So this parameter samplings, these are the arguments. So the arguments go here at the script run configuration, and the parameter sampling goes in the hyperdrive configuration. So I'm putting them in here. I'm telling you have to sample this, or has to run. You have to use this run configuration. These are the hyperparameters you have to sample. This is the metric I want you to monitor. So that is what we did with the logging. We logged the final accuracy of every run. So monitor this one. Then your goal is the higher accuracy, the better. Run 8 jobs in total. So you pick some random things 8 times. and then you can run 8 jobs concurrently. So what it is doing now, it is actually running 8 jobs at the same time. So here we see that it has booted up this job 8 times, and it should start giving us some output now within like a few minutes. So we choose a very low number of epochs, so it should be done very fast. And the cool thing is that it will, oh yeah, here we see the samples, so it has chosen almost all the time the same number of epochs. Oh yeah, here it shows 3, and we can click on these runs to see what is going on. So some of them are here. This one is completed. So here we also see the same graphs. So we can dive in every run and see the output and the input. 2 are running, 1 is completed, 5. So we're almost done here. And in the meantime, we see all these different runs, run 183, 86, on a cool graph showing that run 186 is actually performing the best according to this configuration. So are we done? No, 1 is still running. We're still running. You're still running. That one is booting up. No, that is going very well. That is nice. Okay. Yeah, I was scared of that. So let's see if we can connect to that notebook from here. I prepared me the tuning notebook. Get the right one. So the next thing we can do, are we back? Are we back? Oh, that is a shame. That is hanging. Okay, but we get the gist. It is here. This is the best model. Nope. The window really froze. Okay, so hopefully, why not? Yeah, so our best run is number 186, and this is the best run ID. So now what we can do is we can say here dev days. We can actually register that best run model. We can download it and run it against our test session, and then we can pick it up like the other model and deploy it in an Azure container instance. So here we're doing exactly the same. We have downloaded the model and now running it all over our test set. Then we see that it is doing a lot better on Mr. Burns and also on all the other images. We can create a scoring file and then finally use the Lego inference and then deploy it to an Azure container instance where we can send JSON information to it. Cool. So that is almost what I wanted to show you. Yeah. So what have we seen in this presentation? We have seen how we could prepare and set up our environment with setting up a workspace, creating compute and storage. Then we started experimenting with our model and our data by creating an experiment, training our model and registering the output. Then we could create a deployment configuration and deploy our model to an Azure container instance. So all this is available on AK.automation's Azure Machine Learning AMLS-PyTorch on my GitHub. So I want to thank you all for joining me, and maybe there are a few questions that we can answer before we close off.
Yes, thank you, Hank. So we'll go ahead and take some time for the questions now.
Yeah.
One question is there a possibility we can import Azure Machine Learning Studio experiments into the workspace? I assume they're referring about the Azure Machine Learning Studio Classic version experiments, maybe? Yeah.
Yeah. I don't know, but what I do know is
Mhm.
that there is some information on Microsoft Learn docs available on how you might migrate those things.
Mhm.
Because
Okay,
I
great.
almost never work with a visual interface because I like to touch code
Mhm.
and see everything. Yeah.
Okay. And also we have, can you please brief about the version control and working with multiple environments?
I don't exactly, with the version control, I would just check everything into GitHub like you would do with any other project or any other Git repository, Bitbucket or whatever you want. And then with multiple environments, if you have the config file included in your version control, you just have to say workspace from config and it will connect to that environment. If you mean as environment multiple workspaces, otherwise environments are the environments called in Azure Machine Learning Workspace are the environment where your training script is going to run in. And that is what you specify in your run configuration. So there you can point to different environments to actually see which one is the best for your training. Maybe your model runs as good and as fast on a CPU, and you don't need the expensive GPUs.
Okay, so it looks like we have covered all our questions, Hank. So is there
Yeah.
anything else that is there anything else that you want to cover before we wrap up?
No, just that if you're stuck or if you need more resources, feel free to contact me on Twitter, and I can
Mhm.
always help you and point you to the right resources and the right direction.
Okay, so there you go. So thank you very much, Hank. We're truly honored to have you today with us. And thank you very much for the interesting and informative session as always.